Hey everybody, this is Steve with Install Guys and hoglabs.com. That's spelled with 2 H's for those of you that are not familiar. What I'm doing tonight is a quick experiment. I read somewhere, someone said that you can't heat water with HHO, with a flame, torch, HHO. I don't know where I read that. If any of you find where that was written, I don't know if it's on YouTube or in a forum or something. I don't know why they would say that. But when have you ever known me to hear something like that and not do something about it? Can't remember the last time. Don't think there's ever been a time, actually. But what I've done is I've put together some little pieces, and I'm going to show you a technique that I use. And what we're going to do is we're going to actually heat water. And I'm going to let the camera roll, and we're going to watch the temperature rise and let's just see if that's true or not. Okay? So what I've got here is I've got a brimstone torch. We're producing approximately 4 liters a minute out of our generator. I've put together a little device here that I'm going to use that's going to heat the water directly and allow the HHO flame to burn. Let's take it apart here, and I just want you to see how it's put together. Now what I've got is I've got a 1/4 inch to 1/4 inch compression to 1/4 inch NPT brass fitting. And this is what that looks like. Looks like that. Okay? Quarter compression to quarter NPT. Okay? What I've done is I've tapped the inside with the threads necessary to install a .030 MIG tip. It's a MIG welder, if you don't know what that is. .030 for the orifice size. This, I'm going to term this as the shield, but what it is basically is a quarter NPT to 1/2 inch sweat fitting. It's made out of copper. It's designed to sweat onto a 1/2 inch pipe and allow you to give you 1/4 inch NPT threads. 1/4 inch is the NPT is the National Pipe Taper. Alright, so what we're going to do is we're going to attach these two together. I've already done that preliminary work, and I've already been experimenting with this quite a bit actually, but I just enjoy it so much, and I just want to show you guys. Alright, so now what I've found is you can't just take a torch tip, stick it directly in the water. The problem that you have is that the flame itself produces a lot of turbulence. So that turbulence will allow the water to wick up in the area that the flame is actually being sustained, and can actually put the flame out, which we do not want to happen. We want the flame to remain lit underwater. Okay? That's the goal. That's what we're going to be doing tonight. Alright, so let's attach this to our brimstone. Now the brimstone has a precision pin valve which allows us to meter our fuel and directly affect our back pressure. Alright, so I'm just going to set that at my setting. Now, let's check our temperature of our water. You've probably already seen this on the screen. The water, this was a 1/2 gallon jug, says here, but you probably can't see it on the video. We've got a 1/2 gallon jug. Now, this has been taken directly out of the tap, so this is just plain tap water, which is okay. What we're going to do is we're going to light our torch, put it in there, see if we can sustain a flame, and then we're going to see how quickly it heats the water up. Now, we got to be really careful with this flame because we don't want it to hit the wall. We don't want the flame to touch this glass in any way, because I mean in a heartbeat it'll either burn a hole through it or crack it, because this hydroxy flame is very, very, very powerful, and it'll actually melt the glass very, very quickly. So we want to kind of keep it in the middle of the container as much as possible. Now just keep an eye on our temperature gauge. I'm going to step back and I'm going to zoom in here so that you can actually see this up close. What's happening is inside we've got these eddies that are forming, and you can actually see that visually. What's happening is that flame is heating the water, and that water is rising to the surface. So let me back out of the camera here and zoom in on that spot and let you see what's going on inside the actual container, okay? Alright, now you can see those eddies there that are forming and rising to the surface. That's the hot water. That's the flame is actually heating the water in that vicinity, and that heated water is rising to the surface of the container. Alright, I'm going to do some quick background, just explain what's going on here. Through a process called electrolysis, what we're doing is we're taking water, and with electricity between two electrodes, a positive and a negative, and in our case it can get complicated because you've got neutrals. You try to maintain a 2 volts per electrode, but just for explanation, to make it easy, we've got a positive and a negative, and between those we have electrolyte, which is water mixed with a chemical that allows it to become electrically conductive. We apply electrical current in such a way that the electrical current itself, the electrons flowing from plate to plate, actually upsets the molecule of water and splits it into its two key components. You've got hydrogen and you've got oxygen. We all know that water is H2O. Alright. Now, that gas, that combination of gases, hydrogen and oxygen, those two gases are actually what sends the space shuttle up into space. They use liquid hydrogen and liquid oxygen. That giant white cloud that you see coming out from underneath the space shuttle when it makes its launch, guess what that is? They just made a giant cloud. That's water vapor. Because when you take hydrogen and oxygen and you burn those together, hydrogen being the fuel, oxygen being the oxidizer, they go back to that molecule of water. So the byproduct of this flame is water. That's what we've got going on here. So the actual flame, since hydrogen, since HHO, which is what we've termed this, since HHO is hydrogen which carries its own oxidizer, it can burn in an environment that does not have oxygen, because it provides its own oxygen mixed in the fuel. Alright, let's go back and look at that temperature now. Get that in the camera so you can see that nice and clearly. Got our flame going on, we've got our temperature rising. Keep in mind it's only been a few minutes and we've already heated from 60, we've already gone up 20 degrees in just a matter of minutes. Now this is only a half a gallon of water, so a much larger container obviously would take longer. So what I'm going to do is I'm going to step away, just going to let the camera roll, and I'll fast forward through the boring parts and just let you watch this and watch this temperature as it rises, and we're timing it on the camera here so we'll know how long we've had the flame running in its half gallon of water. Last test I did, I could raise the temperature of this half gallon by 1 full degree in 6 to 7 seconds. So we're just going to let this run, and I'll come back when the temperature gets up to a much higher temperature. I got to be careful because I don't want the temperature of the water getting so high that I break my container. It's not a Pyrex or heat resistant glass. It's just regular glass, and I don't want to destroy it because this is one of my favorite jugs for experimenting like this. So I'm going to come back when the temperature is say in the 140 range.